Hi everyone. Today we are going to discuss about almberts test for convergence, which will be there for third semester ACP of Vijayanagara Sri Krishna Devaraya University. It's presented by me, Ishwar T, Assistant Professor, Department of Mathematics, GUPP GFDC HPLD Vijayanagara. In this session, we are going to discuss about the almberts test for convergence. So this type of test is used whenever there is a series is given. Usually, sometimes the ratio, it is also called as a ratio test, is a fundamental tool for determining whether the infinite series what they are giving and whether the series converges. That means it is a finite or infinite. It diverges. So when we discuss this about D'Alembert's test, usually its logic applies to analyzing the behavior of sequences whose terms are positive, usually wherever they are positive terms, and also whose absolute values are taken. Once you get the sequence, this is true for although also for the series also. For the positive numbers even greater than 0, so we find out the limit L, which is given by un plus 1 by un, where un is the nth term of the sequence or series we can write. So now we find out the limit n approaching infinity. So this, after finding this limit, it is taken from limit n approaching to infinity, un plus 1 by un. If you know un, then you can write an un plus 1 by increasing n to, or by changing n to n plus 1. So once you calculate with the limit, it should be a finite limit. Usually you will get, if it is less than 1, then we say the series or the sequence converges to 0. And if it is greater than 1, then the sequence diverges. Usually it is to diverges means it is in up to infinity. And if L is equal to 1, the D'Alembert's test, what you say ratio test, is inconclusive, or sometimes we can say the test fails. And we use some different techniques or other tests to find out about the convergence and the divergence. You, my dear students, just to remember, for the D'Alembert's test, we usually take this ratio, that is L is equal to limit n approaching infinity un plus 1 by un. If L is less than 1, sequence converges to 0. L is greater than 1, it diverges to infinity. And if L is equal to 1, the test fails, or you can say it is inconclusive. The same thing again, if L is less than 1, the terms decrease rapidly, indicating the sequence shrinks to 0 or it is approaching to 0, and it means that the terms are approaching to 0. When L is greater than 1, the terms grow and do not decrease quickly, so the sequence escapes to infinity. And when L is equal to 1, the sequence may converge or diverge or oscillate, we don't know, and we have to test for the other tests. This ratio approach is particularly helpful for sequences involving exponential terms and factorial sequences and power expressions. So now you can take for example sequences with factorials and powers. If you consider un is given, it is 2 power n by n factorial. So you can take from this you can take un plus 1 by changing n to n plus 1. You will get 2 power n plus 1 by n plus 1 factorial. So now you can find out the ratio un plus by un, which means this term whatever you calculated divided by the un, which gives us 2 divided by n plus 1. So when you taken the limit from n approaching to infinity, so if you substitute in place of n, you can substitute infinity. So it is 2 by infinity to in plus 1, it becomes 0. This means you can say the sequence converges to 0. You can take the second example, sequences with the roots. When are sequence root terms, it means it is up to 1 by n like that. Un is 1 by n, you can find out un plus 1, that is 1 divided by n plus 1. So once you calculate the ratio, you will get n by n plus 1. This you can take n is a common, then you can write it is 1 plus 1 by n, n get cancelled, then you can go for substituting the limit, that is limit n approaching to infinity. So the answer will get 1. So we already say if the L whatever we are getting is equal to 1, the test is inconclusive. Usually this type of test we use other cases, that is we know even approaching to 0, because when you start with the 1, that first term is 1 and second term is 1 by 2 and 1 by 3, they go and substituting the values, so the total it is approaching, the value is decreasing, therefore the last term of the sequence will be 0, then it means you can say it is converges. When you take for a series, the sequence is nothing but a terms. When you take the sum of the terms, then it means total summation of the terms, you will get a series. That is the summation of the sequence, we can say it is a series. Determine whether the series summation n is equal to 1 to infinity. It is n by e power n, converges or diverges, we have to find out using the almberts ratio test. So we already discussed when we have to find out L, that is there we have taken un, now we are taking in place of u, we have taken an, that is the nth term of the sequence or the series. So once you have calculated this total limit, we are going to get 1 by e, that is 1 by e is less than 1, which means L is less than 1, we can say the series converges absolutely. Why we are taking absolutely? It is we are taking considering all the positive. So once the again, if you take the another problem, that is summation n is equal to 1 to infinity e power n by n, this is of exponential nature, then if you calculated the ratio, then we are going to get exponential, that is e it should be greater than 0. We already know that if L is greater than 1, then the series diverges, therefore we can say the series is the diverges using the ratio test. The ratio test is ideally usually sequences for involving factorials and exponential and the power functions, and when L is equal to 1, exactly the test fails, then we have to use the another root test or comparison tests for more information. The D'Alembert ratio test for sequence is similar to its classic form for series, both are same usually you take. The ratio test confirms how quickly a sequence shrinks or grows as the n increases. And you can have the summary of the session. So whenever the limit we take, if L is less than 1, the sequence or series converges to 0, or we can say just it is converges. When we take sequence, we take converges to 0. When it is series, we say it is convergent because it is sum of the terms. If L is greater than 1, we can say if it is sequence, we can say sequence diverges to infinity. If it is series, then we can say it is just divergent. If L is equal to 1, the test is inconclusive. Usually where we apply and determining the convergence behaviors in power series, usually we use this ratio test, and also in the exponential and the factorial sequences also we use the ratio test. Usually it provides a quick insight into how fast the terms vanishes, whether the terms are vanishing or whether the terms are increasing. Usually it is very helpful in infinite processes which comes across in mathematics, physics and engineering. I hope the session is understood by all of you. And for more information, you can study the refer the study material and attend the quiz for the session. Thank you so much.